Friends, here are some highlights from a class that I was just teaching, kind of like a second lesson on electrostatics, testing some ideas that we had developed about the reason things were moving and pulling on each other after we had rubbed them with rabbit fur. So here's the continuation of the lesson with a few more interesting demonstrations. So take a look at this meter stick. Meter stick's made of wood, and I haven't done anything to it. I haven't like rubbed it like I did with the fur or the plastic or anything. But if I get some friction on the foam, now, according to our model, this has a lot of negatives on it, right? And watch what happens when I hold it up to the meter stick. Oops, just move the meter stick. Okay, so now, what's happening? It's attracting the meter stick. How does that work? That it's attracting the meter stick. Do we have a way for explaining this using our model? So here's the idea. Here's the foam tube with the negatives on it. And then the meter stick, so like this. And it's got positives on it. And the negatives shift away from the other negatives. Okay. What are you guys doing? Pay attention. Okay. So these negatives are shifted away from the negatives on the foam tube. And since the positives are closer, the meter stick moves towards the foam tube. Okay. Here's another demonstration. So I just charged up the plastic piece. Okay, and you can do this. You can do this at home. Get like a brush or a comb, anything plastic, charge it up. Works best in the wintertime. But then if you put it next to the stream of water, watch what happens. This is how you become a water bender. See, bending the water. Why would that be happening? So what's happening here? Again, here's the plastic piece. It's got all the negatives on it. And then there's the stream of water. And in the stream of water, there are water molecules. The water molecules have a plus side and they have a negative side. And so what happens? The plus side is closer. And so there is a force. Now, what do we call this force? This is an electrical force. Right? So look, let's back up a little bit, kind of big picture perspective. All we're doing right now is taking note of and trying to explain a new kind of force. Physics is all about forces, right? We've got forces, momentum, energy, but even momentum and energy, what happens there all has to do with forces. We're seeing there's a new kind of force, and that's it. We're trying to describe this new force, like what causes this, right? Like we had the gravitational force. What causes that? Mass. What is mass? It's just a property of matter. What's causing this? Charge. What is charge? We don't know. It's just this property that makes these things happen. Okay. And so this force, it is an electrical force. Okay. In particular, it's the force of the plastic piece on the water molecules. So all of this is just to be showing that our model, our little explanation here, right? Again, this is a model. There are not really little plus signs and minus signs moving around. Okay. This is it's sort of like you could think of it as an analogy for what's actually happening. We can't see down to that level to actually see what's happening. So this is our model that we use, right? It's our representation. Just that our model works. It works to explain what happened with the fur, the plastic, and the foam. It works to explain what happened with the meter sticks. It worked to explain what happened with the water. One more thing to see. Does this work? On the board. Okay. So rub the plastic, the balloon with the fur, sticks to the board. Okay. Our model with the pluses and minuses, can we explain this with our model? Okay. So I want you to draw a charge diagram of what's happening here.